Okay, are you ready? Hello, Confidence London. We are first time here, so a warm welcome to you all. And a little disclaimer about my talk. Please read it. I need to do that, so sorry. Okay, does anyone know what this is from? These guys? Anybody remembers that? Yeah, because the talk will be about blue teaming from the blue side perspective. And we'll get focus on some JavaScript, and also we will try to find an easy and different approach to detection. And of course, you don't need to spend a lot of money for that. This is the talk that allows you to make this kind of systems on your own. So you don't need to waste like $100 trillion for that. And because money is job for someone else, not me. I'm just engineer, so you know. And if we can do it for free, then we will do it, right? So, okay. My name is Adam. I'm more than 15 years right now in the security. A lot more in the IT. I was working at different companies. Right now, I'm in position of cyber threat intelligence team manager in one of the biggest banks in Europe. Before, I was working at a different bank, also in Poland. My colleagues are here, so we can chat with them later. Before, I was working at some AV vendors, like for 9 years or so, and I was admin. I was doing big networks and stuff like that. Okay. Okay, at night I'm doing the same. I'm working 24/7, so it's the same. Okay, about the agenda. First of all, I will tell you what's the idea behind this presentation, why I did that. The second, I will tell you about attacks and detection methods that you can use to detect this kind of attacks to the browser, and we'll summarize it. Okay. The idea, right? Why I just came out with this presentation, because most of the people think that where you are doing that kind of detection of malicious stuff, this is some kind of secret. You don't come out to the presentation and talk about it. No, the attackers know how this kind of systems work. They're disabling that kind of system, so it's better to talk and spread the information to get them more sophisticated, let's say, and more advanced. These attacks are focused not only on financial sector. In Poland, we are seeing that the attackers are doing much more, not only banks, but also insurance companies and ISPs and stuff like that. Everything is injected, so gathering the credentials, grabbing the forms from almost every page. This is an example of that. This is from ISFB inject. As you can see, there is target is .pl, so everything that is in the scope and have a title logovania, which is login. It will just inject and grab the content and the form. So yeah, they are doing a lot more than banking, so this is good for other sectors to learn that kind of tricks. What's the scale in Poland? Because I'm based in Poland, I see the campaigns that are floating in Poland, so I can just talk about Poland. I hope after my talk, if there is someone from bank here in England, maybe? No banks? No. You are from Poland. Okay. Because I would like to hear how the situation looks like in England, right? Because you have a different kind of malware, different families attacking, and different approach to banking. So it's good to know how it looks like. What's the scale? In third quarter of this year, We detected like 1 to 3 spam campaigns, malicious spam per day. Mostly used engine of malware was Danabot. It was using recently. Then the Nemime, Backswap, and many others smaller like rats or something. In every of this campaign, there's approximately like 30 to 70 targets defined in the config file, so it's kind of huge. Almost all the big banks are there, and some Bitcoin exchanges recently, so they're attacking a lot more. And we got highest recorded config, which is more than 300 definitions in the config file. Why 300? Because in Poland we have banks, small banks that are called SKOK. We got like more than 100 of them, and they are using the same banking system, the same login page and stuff like that. So when the attacker is doing config, it just need to define the target, and injects are the same for more than 100 banks, so it's easy, right? So the config is 300 definitions fat. Okay, so this is about the introduction. So we can start. Every presentation should have one funny quote, memes and cats. So this is a funny quote from Sun Tzu. And okay, infection. The most used method in Poland, as we see, is not exploit kits and stuff like that, because it's not effective. You need to have exploits. You need to take care of that. Attackers in Poland use malicious spam with attachments, and they're using a scare tactics, right? So the user is pushed to take some action before thinking. So they are using invoices. So you get like $1 million left to pay. You need to do it now because you will kill your dog or something. We got packages companies like DHL, UPS, and stuff like that. So you have a package, please click here to check where is it. We have telecoms, so you got the bills to pay and stuff like that, so attachment is also that kind. And government, we have sometimes we see campaigns that are imposting as government agencies to you need to confirm something, and it's everywhere. I think is the same. So where to start? How to start the detection of what do you need to know to start? First of all, you need to know how the web browser works, right? You need to know what's done. Does anybody here know what's done? Everybody? No? Nobody? Okay. It's objective representation of HTML in the browser, right? So you can just create dynamic pages and without reloads and stuff like that, in case somebody don't know that. You need to know JavaScript, because most of the detection mechanisms will be using JavaScript. And just to be precise, the better, let's say, raw JavaScript, the base JavaScript without any frameworks, the best, because you need to face some incompatibility issues with the browser. So when you are not using frameworks, it's better. Yeah, and you need to have imagination and ideas, because you need to think how the detection mechanism, where you can place it to be undetectable and stuff like that. So yeah, imagination is very crucial here. Let's move to attack methods. Web injects. Does anybody heard about web injects, how it works? I know that. Yeah, so it's most popular attack method because it's fully automated. It's taken when JavaScript is injected into DOM, it takes over the full scenario of attack, and it's injected before browser renders the content to the user. So user thinks that this is a content of the web page. And it has built-in rules set that overrides the content and injects part of content and stuff like that. And when Injex is starting, it's running ATS. This is Automation Transaction Systems. We call it that way. This is the part of script that takes care of whole flow of the user in the banking. So from the login to the money transfer, it's fully automated in that. This is the part of the config. You already saw that in the first slide. Okay, this is the target, right? Set URL is the target. This parameter is changing from time to time. This is not always set URL, but they're using binary formats, depend. What to replace, what to inject, and where to end inject. This is the block that this is injected. So what is the effect, right? So here you have a simple web page, which is strona internetowa is web internet page. And here you get example inject for that. And the result in the DOM will be like that, right? After the malware is injected into content. Okay. This is how it looks like in banks in Poland, in campaigns. This is after the user passes the password and login and 2FA, whatever. Text scenario is moving to the UI of the banking system and clicking the buttons or links, moving to the, let's say, money transfer form or defined as well-known user, so you don't need to accept the transaction later. It depends on scenario. And after the script did this job, they are just asking for the SMS password, which is 2FA. And it says that alarm system doesn't identify your IP, your computer, your whatever. Please confirm that this is you and give us the SMS password, which is the user thinks that it's confirming the IP or something, but the automation system is taking over the money. This is a different bank. Scenario is the same, but in here the scenario says that there is a bank NRB format changing, so you need to confirm with your new NRB, whatever. It's just a different story to get the SMS code. How to detect that? What is the approach to detect that kind of injections? The easiest method is searching for the keywords, right? You are reversing the malware, you are extracting the config files, you're seeing that scenario, you know how it works, what kind of variables it injects. So you can just make a simple script that is looking for your keywords into the browser DOM, right? So this is just the simplest approach ever. But this is effective, right? It just works, like in Apple. There's a trick. When you are using, your script is loaded from iframe or from embedded tag, you need to jump to the parent frame, so you need to place explicitly that you're going to the parent, because sometimes you don't see the full DOM rendered in the browser. So this is crucial. Okay. The next approach is detecting non-standard or not used JS libraries. When you are not using something, attackers will mostly use jQuery or stuff like that to make the injects smaller, right? There are a lot of framework methods to use. So if your system doesn't use jQuery, for example, you can just simply try to detect that with just a little snippet. When the function is not defined within the browser scope, it just shows an error, so you can tell that jQuery is found or not, and you can decide what to do. But in case of jQuery, you need to remember that jQuery can be run with no conflict option. Does anybody know what no conflict does? Okay, so when you're registering jQuery in your browser, it it's registered globally with the dollar sign, for example. You don't need to pass the full name of the object, like jQuery something. But when you load jQuery and use no conflict method, then you need to explicitly say the name of the framework, right? Attackers know that some systems detects this dollar approach, the global variables definition. So they started to renaming jQuery to some random string or hash or whatever, and running it with no conflict. So they know the name, we don't know. So it's a cat-mouse game, right? Yeah, so you need to take care of that also. You can, with that kind of snippets, you can just take a look at the non-standard variables that you know that you are not using, or functions that you don't know, right? This is a, you need to do a whitelist of your functions and scripts. This is not very stable because there are many toolbars that are like Skype, for example, that is tampering DOM, let's say legally. If you got Skype installed and you have a phone number in the web page, you will inject the icon, call, whatever. So sometimes this detection methods has false positives. So yeah, you need to take that under consideration. You can do DOM part, just part of the DOM checksum. You just want to, make some snippet that calculates some checksum. But we got that kind of attack in Poland. The attack was not, the injection was not on the banking system page when you log in as the user, but on the CMS side. So under the CMS, there is a button, please go to the banking system, and they are starting to inject that instead of banking. So when the user was clicking, it was just pushed to a phishing site or whatever. So we did a detection that was looking at this little button there. We decided what to do. Okay, you need to also take a look at the data containers in the browser with our cookie, local storage, session storage, because it depends on the system, but when you have, for example, a web page that is reloading during the stages, at first step you're placing your username, then the password and stuff like that, the inject needs to pass all this data somewhere during the injects, during the scenario. So they are saving the credentials in the cookies, for example, or any other storage, and then taking from them at the stage that they need it. So yeah, you need to take a look at them. At the time I was creating that kind of systems, the attackers was using mostly cookies in Poland. But after they detected that we are looking at the cookies, they moved to the local storage. And after we made our system better to look at the local storage, they moved to the session storage. So it's, as I said, this is a cat and mouse game. So yeah. Webfake. This is more interesting stuff because it's phishing on steroids, right? And does anyone here know how webfake works? What is it? Have you know the word? You know, because I told you yesterday. Okay, the webfake, it's phishing. It's super phishing. I call it super phishing because it's a method that I will explain that later. So let's skip that. It's hard to detect, really hard to detect. It's almost impossible to detect, but we can, do some tricks to get the detection done. Almost whole communication is redirected to the attacker server. There's minimal set of communication with the real system. Everything is passed through the attacker server, so that's why it's hard to detect, because the user is not using your system, so you cannot see it, how it, inject it or whatever. And everything looks fine from the client side, because the webfake is using a trick that allows it to render a web page with the correct certificate and correct web address. So that's why I'm calling this super phishing, because the user sees the phishing page, but the the green bar and the address is correct. So cannot tell if you are on the phishing side or real side. But this method is less effective than a web inject because it requires from attacker to do manual work. When the user is logging, then attacker need to sit on another computer, push the user through the scenario, fish the SMS code, the password, whatever, the user login, and then log in from the different PC to create some operation, right? And this is also, we got a small talk yesterday about it. And you see the login of this user, you see this is perfectly fine because the attacker is using the normal PC. You can even pass the traffic through the infected PC. So we see it's just a user. There's nothing special with this session. But yeah, this is less effective and less used in Poland. We see that kind of attacks, and we have like 2 to 4 banks that are using, the attackers is attacking with this method because it needs operators, so you cannot just do it like in thousands. How to detect that? Because the user is outside of our system, and we were trying to find some ideas what to do, right? Because there is a clean web page. By clean, I mean they are doing, like on the phishing side, they are doing copy of your web page, checking all the scripts or loading them locally on their server. So they are cleaning it. They are removing all the JavaScript detection and stuff like that. It's clean. But sometimes they are taking the banners, for example, right? So if you have some active content that it's not JavaScript and the user should know that the content exists on this page, like banners, take a loan or something like that, you can just try to use it because it needs to be copied by the attacker to make the page looks the same as banking system, for example. We can also do log-based detection because the attack to establish the SSL channel, TLS right now, the attacker need to send a request to our server to get the certificate and stuff like that. So what they're using, they're constantly, when you see the session flow, they're constantly asking for one resource, for example. So you see there's an example of favicon. So when the user is infected, you see like every 2 seconds, user is using favicons like many times. So it's something weird, right? Yeah, so this is one of the detection methods. We need to correlate the request to the backend. From the user, right. This is only requests from the user, but you cannot... Yeah, but yes. But you cannot see the real attacker because it uses on different PC. Well, it doesn't exist, right? And it's hard to call. But you cannot correlate the sessions, right? So, yeah. But it's weird that you have only favicon every 2 seconds, for example, right? And after we started detection of that kind of things, they are moved forward and they are randomizing this resource. So sometimes they're asking for favicon, sometimes sitemap XML file, sometimes asking only for the root, sometimes only for the head. Their requests have only head, so no content, but it still works. So they know that we are fighting with them, so they are doing things different also. And they are doing a lot of configuration bugs, right? Sometimes where they're doing web inject in the phishing side, the scenario and stuff like that, or phishing. 1, 2, 3, okay. Or malware is, the configuration of malware is, have some errors within the scope of injection. Sometimes it leaks, right? So sometimes we see some requests from user PC. So we can just try to correlate that and then act later. Just a simple representation how it works. Here you have bank, the client is connecting, there's the SSL TLS channel established, and after the browser verifies the channel, the malware which sits in the browser injects the content from different server. So here you just see the favicon requests, right? And here you have phishing server that's serving web fake, and the attacker that is logging into bank using your credentials and taking over the money. I don't know. They are just using favicon. I love this screen. My colleagues, I like. I know that Flash got many of errors and 0 days, but I like it because many people just don't know ActionScript fully and don't know that Flash can run JavaScript internally. So if you have active banners, right now nobody is using Flash, right? So, but in the past, when you got active banners in Flash, you can just place your detection mechanism in the ActionScript and compile it into, let's say, banner and place it on the web page. So when the attacker is preparing the phishing site, it will probably take the Flash banners also. So this is one of the detection methods that you can pass to phishing site. The funny thing was in the first attack in Poland that was using web fakes, it was Dyer family malware. I don't remember really, it was a couple of years ago. They copied our Flash with the detection mechanism. It was not so sophisticated because we were just requesting empty image from the website, from the different website, right? So if you are going to bank domain, this one request was sent to the different domain. And that's why we jump out from the scope of the web fake, so they will not see this request and not inject it, not taking over this request. So we just saw this request for this empty image. And the config was built that way that when the user is moving through the scenario, after the money is stolen, the malware got see in the browser a link that was go sleep, and the parameter was milliseconds. So when the malware saw that kind of address in the request, it just you can just disable it for that amount of seconds, right? So with this simple trick with Flash, we was sending a request to empty image, then doing redirect to go sleep 10 years, and every infected user that was using this web fake the banking system was not loading for him, but we disabled the malware, so the user can just call the helpline and get things fixed. We save the money, right? So yeah, Flash, I love it. You cannot hate it if you have functions like that. Another approach with the active elements and different, tricks that you can use is cats. Yeah, I love it. Okay, what you can do, there's the trick in GIF format. I don't know if anybody knows this trick. At the 5 or 6 bytes after the GIF header, you get a resolution parameter. There's a resolution. You can just start a comment, C-type comment there. And after the content of image, you can just finish the comments and place your JavaScript here. So if you will use this kind of trick and load it like that, the JavaScript will run, right? Because the interpreter, JavaScript interpreter will just skip this part as the header. It will skip the whole GIF content, the garbage, and runs the code after that. So it's easy to hide some content in the GIF. But it needs to be run specifically, so it may focus the attacker attention. No. No, it should work anytime. Not always. Not always. It's working. Maybe they changed something. I was doing this kind of system a couple of years ago, so you know the browser is changing constantly. So, but at the time I was doing that, it was working fine. And the funny thing is that when you this image just from the browser directly, you will see the cat, right? Because the JavaScript is just the garbage. So it's a fun. It just works. Okay. The third method of attack of our clients are what I call clippers, which is the clipboard manipulation stuff, and RAM scanners, RAM patchers, whatever they are called, right? The clippers abusing clipboard. This VB clip is one of the family that we got in Poland that is replacing the data within the clipboard. When your user is copying, pasting the account number or whatever, you just replace it in the clipboard. So the user was not, checking source when doing money transfer. It was just do money transfer someone else. And we got another family, which is Banatrix. I don't know if you heard that name. And Benio, this is a new one, specific in Poland, that was working, patching the NRB directly in the process memory of the browser. So it's also a different approach to injection. This malware was, I don't know, it got like 10 lines of code in C#, I think, but it steals money, right? It works. Users are not so smart and doing stuff they don't want to do. It's very effective. When you copy and pasting the account number, you are thinking that there is nothing you can change in the clipboard. User doesn't know that, and doesn't verify pastes with the source. And it's mostly used in targeted attacks. We don't see that kind of software in the malware campaigns. It's mostly targeted stuff. And we have different detection methods when we talk about that kind of family. When we take a look at the clipboard abuse, we need to force the user to fill up something manually and check with the source. For example, the account number, the target account number, right? So with this JavaScript snippet, we are just checking if the user is using copy-paste, and if that, we are changing class number to a star, to the asterisk, and user need to fill up the last number. This takes the user to the source, and when the account is different than the source, the CRC will just be different, and this kind of attack will not go well for the attacker. And the user hates that, really. I hate that also, so I'm doing copy-paste all the time, and if I need to, just one number, it's pain, real pain. But it works. It saves some money. Banatrix. It's replacing the data in memory, so we can use a bait, right? This kind of Banatrix was looking at the browser process memory fully. It doesn't have any, methods to check some kind of offsets, nothing fancy, right? It just scans for the set of bytes and replace that in the memory. So we can do a simple trick. We'll set a bait on some NRB account on the web page, and with this JavaScript, we will check the base 54 of this bait with the original, which we have coded here, and if it's something different than the NRB was changing in the process memory, right? So we know that client is infected. It's simple, it works. But in some banks, I saw an implementation that they are doing this comparison differently. So in their case, that was always true. So the detection wasn't working. The logic was different. So But yeah, it's still simple, it works. You can just save some money again. But after we started to detect that stuff, the memory scanners, we saw Benio. This is own name. This malware was only floating in Poland. Our colleagues one of the clients of our colleagues just got this into targeted attack. And the approach was different. It was also patching the memory, but it has more advanced built-in pseudo-regex mechanism that was used. So the detection mechanism that I showed you previously was looking for a simple NRB, right? And in this case, the config file was looking for some part of the strings that are on the web page. So if you have, let's say, this kind of quota, VAOD, this is when you are on the define money transfer page, you see VAOD is the name of the destination account or name of the destination. It was different. And SNIE-CON was show only contacts from the contact books in the bank, right? So this kind of pseudo-regex works fine because the malware activates and patches the memory only if the user is on this page, right? So it was a different approach. We changed our detection mechanism to act more in every web page. We need to check that kind of stuff. Yeah. And we have archive. In the archive, I placed the methods that are no longer used in Poland. I don't know how it looks like in other countries, but it was like, I don't know, 10 years ago when this method was used. The simple one, it was replacing bank when user was sending after the filling the form, it was sending to confirm the operation. It was replacing in the post message. Simple trick. And they are not using that anymore because most of the banks are doing translation. So in the post message, there is a real NRB number, but destination number, but just a set of digits or letters that only bank know the pattern in the backend. So we know what is the destination, and the attacker cannot replace it, just like that. And it works. We have a couple different methods that people are thinking that will help them to detect malware. One of these methods is CSP, Contact Security Policy. In short, I will not get into the details. It's resource whitelisting. So, yeah, most of the malware right now just removing these headers or damaging them, somehow replacing letters and stuff like that. So it just doesn't work. So the funny thing is when the banks was starting to using whitelist resources that are loaded into web page, the attackers was disabling this CSP headers by changing the letters, so the browser doesn't understand that. But they had one issue with that algorithm built in, because when you are sending the same headers to the browser, they was damaging only first one. So still, we got a detection because the second one was still working, right? But they already fixed that, so it's useless anymore. We have HSTS, Strict Transport Security. It just prevents protocol downgrade. It works with some phishing side, but it doesn't work anymore with normal malware, so it's useless. And we have HPKP, public key pinning. In short, certificate pinning in the browser, but nobody is using that because not business savvy, let's say. You need to take care of this pinning. And if you are doing this wrong, then you can just disable your banking page, right, for a long time. So nobody is using that. It's very risky. So just to summarize, because my time is almost over, but they're removing this detection, right? We are placing the JavaScript, they are constantly removing that damaging and stuff like that. Who cares, really? It's just a simple code. It's effective. When they are damaging it, we're just placing it somewhere else. It's just a snippet, so it's a game, right? So at my career at banks, the simple was always working. You don't need system for like $3,000 billion to get it done. Make it difficult to disable it. And the good approach is to ask your developers or the companies that are doing your web page to build that kind of mechanism into the content of the web page, deep down the content, right? So the deeper it gets, the harder to notice that. It's just a game, remember, right? And the criminals are not sleeping. They do have some tricks also, but we have also our tricks, right? So it's a game. I remember like 2 years ago, there's a problem with when you are updating that kind of scripts from your side, let's say bank, you need to have all the QA process that the scripts will not break anything. The banking system is still usable. And this is a problem because changing something takes day, two, whatever. And the attacker got 5 seconds, maybe, a minute, just changing the config, push it into malware, that's it. It just worked. And this is a game, I remember a couple of years ago, I was fighting with that kind of stuff at work. And the attacker was changing the script, we were changing the detection method. And it was like 5 minutes periods, right? And we won. So after like 2 hours of 5-minute constant changes into detection, we won. The guys went sleep or something, I don't know. But yeah, it's effective. You can, as I told you, this is something that you can use a different approach for that detection. You need to have imagination how to use file formats, for example, how to abuse them sometimes, how to abuse the response headers, stuff like that. This is a game, right? So you can, another trick is to embed your detection mechanism somewhere in any resource that you are loading in the web page. Like for example, this is blank PNG. This is a simple empty file of graphics. And after the file format, you just place, this is a reversed base 64. Just, you know, like a virus, right? You are embedding something into resource and making a simple loader for that will run this. So you can just request for this image, act like ad server, whatever, Google Analytics, just do what you want, name it as you want, and just load and run this content, and that's at the end of the image, right? So it's easy, it's fun. Yeah. Thank you. That's it. If you have any questions, please, we got like 1 minute and 10 seconds. And if you want to join me at the drink or something, we can chat about the detection mechanism. So thank you very much for coming. I hope you like it. And see you at the bar.